Good morning and welcome back to Broderland. Mr. Brodeur's here on week 6. We are currently on day 3 and we're still on rotation. So yesterday we talked about rotations using a point and rotating it on a graph. Today we're going to up that a little bit and look at images and rotating an image. So let's take a look at our learning intention really quick. It says students can rotate a two-dimensional figure on a graph, either 90 degrees, 180 degrees, 270 degrees, or 360 degrees. And also understanding that when we rotate our original figure, or what we would call our pre-image, that when we rotate it and get our new images, that would also be congruent. All of our images are going to be congruent. We're not going to expand or make things larger or smaller. They're going to stay the same size. All we're doing today is rotating. So let's go over to the side. Let's take a look. Now, if you were with us yesterday, these top 3 images will look very similar because, of course, we used our formulas. We're going to use our formulas again today. Also, yesterday we talked about what it looks like to move clockwise and what it looks like to move counterclockwise. If you need a better understanding of how clockwise works and counterclockwise, look at our video from yesterday. I don't want to get too bogged down on how all that works, but if you want to see it again, watch the video from yesterday. Just remember, clockwise is going to go the way of the clock. So if I started at the top, it would go right and around. Counterclockwise, of course, is the opposite of the way the hands move on a clock. So it's going to go to the left and around if you start on the top. So those are just a little bit of refreshers. Again, check the video from yesterday if you want more details or a better explanation on that. But let's jump into our first example. Now this is actually, I believe it might actually be the first problem for practice problems that you need to do. So this is going to be good. We'll work out one together. That will leave 3 more problems to do on your own. But let's take a look. It's asking us to rotate 180 degrees about the origin. Now this is also a little refresher from yesterday. What we're doing is, of course, the origin is 0, 0 right there at the middle. And what we want to do is rotate our image around the origin or about the origin. So it's going to be kind of rotating either this way or this way. Now, let's talk about that. Which way is this rotating? Usually it says 180 degrees clockwise or counterclockwise. Why doesn't it say it here? Well, if you think about 180 degrees, and I'll demonstrate standing up right here. If I was looking at the camera and I turn 180 degrees this way, I'm looking at the door right here. Now let's say I decided to rotate the other way, 180 degrees. I still get to the same spot, the same position. So when I look at this problem, whenever you see 180 degrees, it's not going to specify clockwise or counterclockwise because it doesn't matter which way you move, you're going to get to the same place. And if I come up here to our formulas, you'll see 180 degrees clockwise and counterclockwise. You use the same formula for both, whether it's clockwise or counterclockwise. So 180 is the time where they may not specify, but 270 and 90, they really have to specify because it does matter. So let's take a look. Rotation of 180. I'm going to write the formula we're going to use. Looks like negative x and negative y right there. Okay. Now, remember, these negatives don't necessarily mean negative. They just mean we're going to change the sign of our x and y points. Now, of course, we need to find those for each coordinate. So let's go to our graph. We're going to start at the origin. I'm going to find j first. So j is 1, negative 1. So I'm going to do 1. Whoops. I guess I'll do blue to match up blue right there and red for red. So we'll do 1 and negative 1. Now r right here, we're going to go 1, 2, 3, 4. And then 1, 2, 3, so it'd be 4, negative 3, because we had to go down right there. Y, 1, 2, 3, 4, 5, so 5. And then 1, 2, 3, so negative 3 since we went down. V, 1, 2, but we didn't go up or down any, so that's just going to be 0 right there. Now, of course, what we want to do is use this formula, find our new points, and then we can plot those in there. Now, all this says is it looks like X and Y are going to stay put. Remember, X is first, Y is second. All we have to do is change the signs of our X and Y coordinates to the opposite or to the inverse. So right here, this is a positive 1. Now we're going to make it a negative 1. And I'll use a red right there to match up with the red. Negative 1. All right, this is a negative 1, but it says we need to change it to a positive 1. Now, some people might say, oh, all we did was switch it. Now, be careful. I didn't switch it. I know it looks like it. I just changed the signs. This is going to demonstrate it a little bit better since it's not the same numbers. 4, we got to change it to the opposite, or the inverse. So negative 4 right there. Change its sign. Negative 3 is going to become positive 3. This would become negative 5, positive 3, negative 2, and then of course 0 is just going to stay 0, whether it's negative or positive. So that's all you're going to do. Now again, some of the other questions you'll have to do in just a little bit, you may have to use a different formula. So just keep in mind, you're not always going to use the same formula. I'm just using this formula because it's 180. Now we're going to go and plot these. Now this is a good way to double check that you're on the right track. I have my graph right here on the bottom right. And I know it's going to move 180 degrees. We said each quadrant is 90 degrees. So if I decide to go counterclockwise and rotate it 90, 180, it's going to be somewhat in this quadrant. Same way if I moved clockwise, 90, 180. So what I'm hoping for is when I plot these points, they should land somewhere in this quadrant for the most part. Just because that looks like where 180 degrees is going to move. So I'm going to go to negative 1 up to 1. And I'm going to put J prime. Make sure you keep up with that. Label as you go because you don't want to forget which point goes with what letter. Then we'll go to negative 4, 1, 2, 3, 4, up to 1, 2, 3. That looks like that was R prime. And again, make sure you have your primes as well because these are your new images, not your pre-image. Negative 5, 1, 2, 3, 4, 5, and 1, 2, let's see, what was it? 1, 2, 3. And what was that? That was Y prime. And then we have V prime. That is negative 2, 0. So we'll put V prime right there. And it looks like I said, it should land in this quadrant. That's 2 quadrants away, which would make 180. So now all I need to do is connect my points right here. Like that. And I got my rotation situated. It looks like it has rotated successfully. I'm in the right quadrant. I got my primes. I got my letters. I'm good to go. And that's everything you need to show for the rotation of 180 degrees about the origin. Do the similar thing. What I would do is I would write down my original coordinates for my pre-image, find your formula, change the coordinates, and then go ahead and plot for your other practice problems similar to this. Now, the last one we got to talk about is write the rule for the relation. So when I do this one, you could get 2 answers. Now, this one is not the exact one that's on your paper. I chose a different one that I found online just to kind of show you what I would do. And then that way you can create your own rule for the one that's on your paper. This is what I usually do. You have to pick which way you want to go. It does not matter. Like I said, you can either choose clockwise or counterclockwise. I'm just going to pick a letter. Don't let this be too overwhelming. I just pick a letter and figure out what's going on. I'm going to just start with K. You could start with any other letter. Now remember, you want to start with a letter that is not prime. Like I would not start with B prime because that is my second image. You want to start with an original image. So I'm going to start here with K. And I'm going to see how many quadrants K prime moves away if I go clockwise. So I'm going to choose to go clockwise. And it looks like one quadrant away. K prime is, here's K. K prime moves to this quadrant, which is one quadrant away. So that looks like I'm going to rotate 90 degrees clockwise. Now, let's say you wanted to go counterclockwise. Then I would take K right here. I know counterclockwise would move around from left and around like this. So K is here. I don't see a K in the first quadrant. I don't see a K prime in the second quadrant, but I do see it in the 3 quadrants away. So that means I would have 90 plus 90 plus 90, which would be 270. So if I just decided to do counterclockwise, that would mean we would rotate 270 degrees counterclockwise. And I'm running out of room right there. Boom. Okay, that's all you need to do when you write the rule. Just pick. Notice I didn't really worry about the other letters. I just worried about one and saw how one got to the other, because sometimes it's just so complicated to look at the whole image and then figure out what's going on. So just pick a point. Remember, start with a point that does not have a prime and then find its prime form and see how many quadrants it is away, which would help you find how far it rotated. Okay, so I hope this helps explain everything, especially with rotation. I know rotation isn't necessarily the easiest out of all the transformations, so I really try to make it as easy as possible so it helps you guys at home. So just let us know if you have any questions. But until next time, Brodeur out. Peace.